Hi, my name is Leonardo Daniel Casomedina. I'm a student mechatronics from the UT of Altamira from the group 5th A. Today, we're going to see how useful is the for loop in Labview. We will be simulating the control of a temperature system. We're going to set some alarms, one of for a high level and one for low level, and also some LED indicators, and that's basically what we are going to do. So let's start. As I said, we are going to use a for loop, so we first have to go to structures, select the for loop, and we select the area where we want our for loop. Sorry. After that, let's think what we are going to need. We are going to need uh, an indicator, so we uh, right click on the eye and select create indicator. So here we have our indicator. What else we need? We need obviously a thermometer. Uh, so we give a right click on the front panel, go to numerics and select thermometer. Give a left click and let's make it bigger. This is not necessary, but it is better to have it uh, bigger because it's more visual at the time of running the simulation. So we move the thermometer here. You can put it where you want, whatever you want it, but I'm going to put it here because I have already made a design and I like it to be here. Now, we the for loop always begins with the I variable at 0, but uh, we have to set the limit. So we're going to create a constant, right clicking the end, and then just introducing the value. Our thermometer has a high limit of 100, so we have to add 1 unit to that to make the complete iteration. So here we have our limit. Now let's add some LEDs. As I said, we're going to put uh, a visual indicator, I mean a LED, at 85. And we are going to set also a low temperature indicator at 15. So here are our LEDs. Also, I said we were going to put some sound alarms. So, sorry, the alarms are here. The beep.vibe. We're going to put auto alarms, 2, one for each case for the low and the high. And now we need some comparators. We need to make some comparisons. We're going to compare uh, our value of I with a constant. For the low temperature alarm and LED, we need a constant of 15. We're going to compare if I is lower or equal to 15, the LED should be turned on. Okay, and the same with the alarm. And what we have to do with the high temperature alarm and LED is that we have to compare a constant of 80, 85 with our I. If our I is greater or equal to 85, our alarm should sound and our LED should be turned on. So let's add those. We we go to functions, to comparison, and pairs lower or equal. We're going to be using 2 because we have or sound and or LED alarms, and let's give to X the value of Y, and to Y the value of 15. So here we are saying if for I is lower or equal to 15, you have to turn on the LED. Okay. Now here it happens something different with the alarm, with the beep.by. We have to connect inverted the inputs. We have to put to the Y to the I, and the X to the 15. I really don't know why, but this happens. I have already tested it, and it happens. I think it's maybe because this turns on with zeros. I mean, it's inverted. I really don't know. And then we add the other comparisons. We go to functions, comparisons, and we select the greater or equal. As I said before, we are going to use greater or equal for the high temperature alarms. We connect it to here, we connect it to here. Here you can see that we have three inputs in the alarm, in the beep.by, but let me explain that a little bit further. Mm, Now, the X to the I in the case of the LED comparator, and the constant will be on Y. So again, here we are saying to this comparator that if our I is greater or equal to 85, this should send a signal to turn on the LED. And remember, here is the complete opposite. You send the Y to the I and the X to the constant. Now, here we have two different parameters. This is the frequency. The frequency will determine the sound that this alarm will produce. If the frequency is lower, it will sound a little bit like a dark sound, but if we increase the frequency, it will sound lighter. And we're going to select for the higher frequency, and for the lower, we're going to create a constant with a lower frequency, just to make a difference between the two. And the second parameter is is the duration of the sound, how many milliseconds it will sound. We're going to set the same value for both. I'm going to put 100 milliseconds. I already have it, and that will be pretty much everything. So now just let me move this a little bit. And here, just let me change the name. High, low. So let's give it a run, and let's see what happens. Oh, yeah, that's true. We forgot, well, I forgot to put here we go to timing, and we put a wait, and we set a constant of, let's say, 300 milliseconds. This is this determines how fast the temperature will increase. It's like a delay between each iteration. So let's run it again. Okay. First stop it, and now run it. As you can see, it's below 15, so it is beeping. I don't know why. There it continued beeping, and when it reaches 85, it should beep again, but with a different frequency. So as you can see, the program works at the 90%, I will say. I don't know what is happening there with the beeping, but I think it's a pretty good example. So that will be everything. Thank you so much.